All right, let's solve some quadratics here, look in a variety of things. Our general strategy for these, as it says up here, is going to try to make it look like I'm finding the x-intercepts or the zeros or the roots of a single quadratic because I have the skills to do all of that. So this one, if I'm looking for zeros, the general process is I want it to look like a quadratic equals 0. So it would be a reasonable first step to subtract 78 from both sides of this, because finding zeros or x-intercepts or roots involves making the output equal to 0. So it'll make this look like a quadratic equation. What's that going to be? 84. That is set equal to 0. This one happens to be in vertex form. So my strategy for vertex form was to use an arrow diagram. So we're adding 4, squaring, multiplying by 3, and subtracting 84, and getting 0 as a final answer. So I need to work my way back to the g here, which is going to start by adding 84, and then dividing by 3, doing a plus or minus square root, and then subtracting 4. So 0 plus 84 is 84. 84 divided by 3 is 2, 24, 28. And then to the 28, I do a plus or minus square root. So plus or minus square root of 28, which simplifies because that's 4 times 7, so plus or minus 2 root 7. And then subtract 4 from that, so my answer should be negative 4 plus or minus 2 times the square root of 7. This particular problem had this interesting entry tip here. When people write problems for WAMAP, they have lots of different choices of how they want the answers entered. And so this one says you can, for this problem, type both answers in at once. We have a negative 4 plus or minus 2 root 7. So we would, into the answer box, do negative 4, hit the plus, hit the subtract. We've got a 2, and SQRT will make the square root symbol with a 7 in it. So putting this in the answer box should get me there. Okay, so there's an example that works out to be a vertex form. We get it set equal to 0 and solve it from there. Okay. Here is another one. The reason that this one is not ready yet is because it doesn't say equal to 0, which is what I have to do if I'm going to find those x-intercepts. So I'm going to add 3x and add 20 to both sides and change this into a negative 2x squared plus 3x plus 20 is equal to 0. Okay. And I may spend a little bit of time seeing if I can factor this. If I was going to factor it, we'll use our area model to help with that. This is going to end up being a negative 2x squared. This is going to be a 20. So I'm looking for two numbers that multiply together to give me negative 40, like the negative 2 and the 20 do, and add together to give me 3. The 4 and the 10 are too far apart. 20 and 2, it's obviously not going to do it. 8 and 5, however. So if I had a positive 8 and a negative 5, that would give me a 3. So I'll put an 8x and a negative 5x. And then I can see and hear that I could factor a 2x out of this, which would make this a negative x. That would make this a 4. That would make this a 5, and the 5 and the 4 make the 20. So this factors into negative x plus 4 times 2x plus 5 equals 0. And this, from its factored form, I can solve with the zero product property. So either negative x plus 4 equals 0, or 2x plus 5 has to equal 0 in order for that product to be 0. Adding an x to both sides says x being 4 is one of my possible answers, or 2x would have to be negative 5 and x would be negative 5 halves. This one said list the solutions separated by comma, so I've got 4 and a negative 5 over 2 in the answer box. So those should be my two solutions for this one, reduced to, again, to a factored form. We're able to get there and find the x-intercepts from the factored form. Okay. Finally, this one looks like I've got one quadratic in factored form is equal to another quadratic in the standard form, but I have to make this look like a single quadratic. So that's going to start by, first of all, multiplying this business out on the left. So I've got 5z plus 12 and a z minus 12. That's going to be a 5c squared, z squared, sorry, plus 12z minus 60z minus 144. So my left side is a 5z squared minus 48z minus 144, and that is equal to z squared minus 3z plus 11. If we get them all together now, so I'll subtract a z squared, add a 3z, and subtract 11 on both sides. That will leave me with a 4z squared minus 45z and minus 155 is equal to 0. No common factors that I can pull out of there, so I'm trying to find the x-intercepts, or the zeros, the roots of that one particular quadratic here. If it factors, there's a lot going on in that factoring. 4 times a negative 155 is like negative 620, and thinking of things that are multiplied to 620 but are 45 apart is a little daunting in my head right now, so I'm going to go straight to the quadratic formula and say my a here is 4, my b is negative 45, my c is negative 155, and so the answers are going to be the opposite of b, which will be a positive 45, plus the square root of 45 squared, which is 2025, minus 4 times a, which is 4, times the c, which is negative 155. We'll figure that out here in a little bit. All divided by 2 times a, which is 8. So we've got a 45 plus or minus the square root of 2025 plus whatever, it's going to be a plus because I've got a minus and a negative in there. So 16 times 155 is 2,480 over 8. So this is a 45 plus or minus the square root of 4,505 all over 8. Now, there's a question of, does that simplify? Possibly. It's not divisible by 9 that I can see. It's clearly divisible by 5. Let me try to factor 5 out of that and see what I get. So 4,505, if I factor tree that a little bit, that's going to be 901. Is 901 prime, or does it factor? I am not sure. It doesn't pass any of my easy tricks. It's not divisible by 7. No, it's not going to be divisible by 11. It's not divisible by 13. battery's dying in my calculator. I suppose I could try to divide it by 17, but it would have to be divisible by 17 squared, and which is 289. So I think that this is as nice and clean as that's going to get. So if it wanted these answers, I can't remember how it wanted solutions separated by commas. So one would be 45 plus the square root of 4,505. You want to put that in there, divided by 8, comma, and then the 45, that's 4, minus the square root of 4,505, divided by 8. Those are my two answers. And the palette in there to help you clean those up and make them look a little bit nicer is workable as well. All right, so there's a few examples of what those kinds of problems might look like. So one that we did from the vertex form, one that ended up being able to be made into a factored form, and one where we had to rely on the standard form and the quadratic formula from there.